All right, great. We'll get started. A few more stragglers coming in. Hello and welcome. Thank you all for coming to Couchbase Connect Europe. Thank you all especially for coming to this presentation. My name is Perry Krug. I'm a principal architect with Couchbase based out of our London office. And today we're going to go through, or I'm going to go through an overview of the Couchbase Data Platform. From a technical perspective, we're going to have a exciting demo by my colleagues from the Manchester office, and then we'll have some Q&A time with our CTO Ravi towards the end. So let's get in. Some of this material you will have seen during the earlier sessions today. I'll go through it relatively quickly, but just helps frame the context of what we're talking about. It should be well understood that everything around us is changing, this idea of a digital transformation. But what's really changing the most is the volume and variety of interactions that all of our customers are having with our platforms. If we look across a couple of the different industries, where once you would go to a travel agent, he or she would look up a couple flight options, give you the best one, you would book it and you'd be done. The relatively close ratio of the looking to the booking. Same thing with shopping. You might go into a store, God forbid, or actually look online for a couple different products and choose to buy them right there. But what has happened over the last 5 or 10 years or so is a massive explosion in the first half of those equations. So according to some statistics that Amadeus has been giving us, they're now seeing hundreds of thousands of looks to a single book. And that means they, as a platform, as an application, are needing to support a much higher degree of interactions before they get the actual kind of financial transaction. And for all of those interactions, customers are expecting them to be feature-rich, personalized, fast, available, stable. They're expecting them to work offline. And if they don't work, and we all know this on any sort of app that rolls out a new feature or a new application, that first time you get an error message or the first time there's a little spinning circle that doesn't work, you're very, very unlikely to try that again. So it has to work. It has to always work. And as we saw earlier today, at least 90% of customers are going to go to somebody else, go to a competitor, or not come back to your business if you can't supply that experience. So here we are today saying that in order to deliver those experiences, deliver those engagements, we need to talk about a new database, a new way of bringing the data to and from the users. Why? Because relational databases are not fit for that purpose. They were designed in a world where a few hundred, maybe 1,000 users were interacting with a monolithic application, and the expectation of those users was that the application would sometimes be available, it would have distinct periods of downtime, and it would be changing maybe once a year, maybe twice a year. Fast forward to today, and even the smallest of applications are expected to reach thousands, tens of thousands, millions of users. They're expected to be available all the time, and they're expected to evolve and change many times a year, many times a month, in some cases many times a day. New features are rolling out, right? Facebook, Google, and Amazon have all conditioned us to expect that sort of experience from everything else that we have in our lives. And so as Peter was talking earlier, every time a organization brings out a new level of experience, that raises the bar for everyone else. So relational databases weren't built for that kind of application, development, production, scaling. They have challenges with agility and flexibility because of the rigid schema and underlying implementation of that. The performance is very, very challenging to manage at any sort of scale, either extremely expensive because of the hardware requirements or extremely complicated in terms of replication and geo replication and whatnot. And then from a management perspective, managing the sharding, managing managing the caching layers, managing the changing of schemas is all extra complicated with a relational database, and not to mention one that you're trying to keep online all the time. So where we are today and what Couchbase has realized over the years is that relational databases, okay, we agree, were not built for these types of applications. But they do what they do very well, and they need to continue doing that. But there's a new class of workload, a new class of application, systems of engagement that need a database that was designed for them. And that's where Couchbase comes in as an engagement database. There's no thought that relational databases are going to go away entirely. You still need to support transactionality. You still need to support the actual movement of money from one place to another. But all of the meta traffic, all of the looks and the searches and the interactions getting to that monetary transaction, those things are not well served by a relational database. So if we look at the Couchbase Data Platform, we go back to those three kind of key pillars. We're talking about unmatched agility and flexibility. So that's both at a development level from a data modeling and support for JSON. It's also at an operational level, being able to scale and change topologies, deploy onto a variety of different platforms. Performance doesn't just mean raw speed. There are plenty of very fast technologies out there, but being able to provide that speed consistently, being able to provide it during the course of maintenance or failures or scaling. So that's what we talk about performance at any scale. And then ability to manage the platform. Yes, it is a distributed database. That doesn't mean it should be complicated and hard to manage. That doesn't mean that you shouldn't be able to replicate geographically or within a data center. And just for some last kind of marketing discussion, if we look at the IDC report that Peter referenced earlier today, from a flexibility perspective, our customers are seeing at least 19% kind of faster development cycles, getting a feature, even a small feature, out to market that much faster. Being able to provide 40% faster response times. We all know that a faster website, a faster app means your customers are going to feel more comfortable using it and continue to use it more. And then 37% more efficient database management. Again, those things, complicated tasks of sharding, replication, upgrades, all of those are very, very easy with Couchbase, and we're going to see kind of why later on. And all of that culminates into what was measured as a 274% return on investment from our customers that are using Couchbase to build their digital applications. Okay, so that's enough of the marketing and statistics. Let's get into some of the more technical details of how Couchbase has come to be. We started with a few kind of core principles. And the lifetime of the product has closely mirrored the lifetime of our customers and their needs. So starting off with very simple caching layers and key value storage, adding support for JSON, for more complex querying and indexing, adding support for full text search and mobile synchronization, soon to be and developer preview, support for real-time analytics. All of this built on a memory-first architecture designed for clustering and auto-sharding from the start. So a number of other technologies started off as single node databases and have added on replication and clustering as the years have gone on. Couchbase started that way from the very beginning. We take an asynchronous approach to everything we do, and this allows the software to continue performing even as more and more load is put on it. It allows the behavior to remain consistent and also gives us the ability to have tunable consistency, tunable trade-offs of performance by taking asynchronous and wrapping it in a kind of synchronous model gives us the benefit of both worlds, and you, the application, the ability to trade that on and off. Obviously, being heavily focused and supporting JSON gives us a wide degree of flexibility in terms of data model and evolving of schema. And then one of the interesting innovations, and we'll talk about this much more later on, is the ability to scale the workloads within a database independently. We've taken a very microservices approach to how a database should be deployed, which gives us much greater degrees of flexibility and performance and scale. So this picture you may have seen earlier is what we call the Couchbase Data Platform. The architecture here, you see in the middle there, that's that core database engine, the core key value engine that is elastically scalable, memory first, and on top of that, then we've added query and search, mobile synchronization, analytics, and more capabilities to come in the future. Across the top, a unified programming language interface. This comes both from our SDK that we provide that gives you a single point of entry into any Couchbase cluster, and also our reliance on SQL for our query language that we'll talk about a little bit later on as well. And then on the left, security is paramount to any sort of database discussion. Couchbase has end-to-end security, both for out at the edge, across the network, and down to the disk. And where are we? To the right, integration with the broader SQL and big data ecosystems. Couchbase, we know that we are not the only technology in your stack. We know that playing well with technologies like Kafka and Spark and Hadoop and the other big data technologies is an important part of building out an entire application. And so Couchbase makes it easy to either ingest or send data to those. And then finally, across all of this, Couchbase is supported across multiple infrastructures. So physical hardware, virtualized, containerized, and any of the public or private clouds. Another concept that we talk a lot about is this idea of full stack management. And so this is kind of where Couchbase you may see Couchbase fitting into your environment. You may be writing an application in C or .NET or Java or Node.js, but it's your application. It might be running on an iPhone or an Android device. But no matter what application you're developing, you have three kind of basic tiers to contend with. You have the client tier, which is either the browser or the device that you are making your application available on. The middle tier, where a lot of business logic and services exists, and the database tier, where your actual storage resides. For many years, and even continuing today, a large majority of our customers develop their whole application on top of Couchbase Server. That's the scalable document database, and it's your job as an application developer to take care of the rest. Right? You have an SDK that interacts with the database, and you worry about moving the data from the database layer through your middleware and onto the client. But there's a little bit more that Couchbase has to offer. And the middle layer, this layer is also where you have a lot of the integrations, both replication and Kafka, Hadoop, Spark, monitoring, ETL tools out of the database layer. But at the middle tier, we have something called Couchbase Sync Gateway. And this also provides data access patterns without actually storing the data. So whereas Couchbase Server provides an API through an SDK, Couchbase Sync Gateway provides a REST API, batch, and stream APIs so that you don't have to manage that yourself. You configure this to provide those as data services. And then most commonly, this can act by itself. Most commonly, our customers are using it with Couchbase Lite all the way out at the client tier. And Couchbase Lite is an embedded NoSQL database that gives you full CRUD, query, search, replication out on the device itself, much more than just a caching layer that you might be familiar with, but actually an embedded database that supports fully offline functionality. And then wrapped all around this is a pluggable security layer. So we have security with role-based and pluggable authentication, authorization, and encryption all the way from the edge back into the data center. And so we're going to start looking at some of the pieces of how this actually works and how you might interact with it. We're going to focus mostly on Couchbase Server for today's discussion. There are other sessions and a lot more kind of discussion to be had about the other layers. Taking a quick look at some of the new kind of data management landscape and where Couchbase fits in. You see a variety of technologies all in this broader ecosystem. I'm not going to go through all of the layers individually, but where you see Couchbase's kind of sweet spot and core capabilities in this user-serving, in-memory data serving layer, either taking data in from your users and or serving it out. Another way of looking at that is in a kind of Lambda architecture layout where you have data coming in from a variety of sources, whether it's your application or services that you're pulling in from. And you have it processing through a batch layer across the top and a real-time streaming layer across the bottom, and then eventually being served either back to your application or onto another application that is consuming it. You can see some of the common technologies like Hadoop and Kafka and Spark existing at their own layers. And then Couchbase comes in for either the real-time streaming layer, taking data in as an ingestion layer, and or serving it out. And so many of our customers are using Couchbase in all of these places as a kind of cyclical database, or have chosen only one or more places depending on where they get the most value from. So I hope that gives you maybe a very fast, but an overview of where Couchbase fits into these environments, the types of applications and the types of workloads that we are primarily focused on. We're now going to go a little bit deeper into the technology. Two of the key principles that that I mentioned earlier and that we have tirelessly focused on is the ability to develop with agility and operate at any scale. And to be able to do those two together is really what all of our applications and our customers are demanding of us, and where they are finding other technologies not suitable, either relational databases or some of the other NoSQL vendors. And so there's a variety of features that we're going to go through that Couchbase has developed and brought out in support of these two kind of core pillars. So first off, development. Developing with agility means being able to bring your application features out to market faster, incrementally, so that you don't have to build a monolithic application and then deliver it all at once. You deliver it in pieces, and you can build and expand upon those as you gain more and more feedback. And all of that requires a very flexible schema or data model underneath. Couchbase and many others have chosen JSON to be that data model. Couchbase also supports any non-JSON data in binary form, so storing blobs in the database, but the vast majority of our functionality is focused around using a JSON data model. We're going to talk a little bit more about how this operates with our query language and data modeling in the later sections. But before we do, just some kind of key concepts that we're going to refer back to. Data in Couchbase has a key, a document ID, and a value. And that value can be anything up to 20 megabytes. The vast majority of cases, it's much, much smaller than that. The key can either be, this document or this item can either be key value pairs, so storing strings or integers or serialized objects. And in that case, Couchbase operates and exposes itself to you as a key value store, storing those opaque blobs. You can also store JSON documents. And the nice thing about Couchbase, you can store these side by side in the same database. And so when you have kind of a mix of data, you don't have to worry about segregating it. You can keep it side by side. And even as key value, you still have quite a bit of querying and indexing because the key name itself is recognizable to Couchbase. And so you can do range queries and searches off of that. When we see how all of these items or documents get displayed across a cluster, some of the terminology that we're going to use, a node is a single instance of Couchbase installed somewhere, be it in a container or in an Amazon instance or an Azure instance or a physical piece of hardware. Multiple nodes come together to form a cluster, and then a bucket is our word for a database, a logical grouping of unique keys within a cluster, and you can have multiple buckets within a cluster. And then the documents themselves, those records, usually JSON, but don't have to be, are then distributed into the bucket. The keys need to be unique within a given bucket, but you can mix types. And so rather than think about a bucket like a table, think about a bucket like a database that's going to have multiple tables within it. So you may have your orders and your customers and your company documents all as separate document types, all within the same bucket, because that bucket is what's serving your customer order application. And then when you're coming to access Couchbase, there are a variety of tools, a variety of ways that you have to get access to the data. We'll talk about the kind of underlying architecture a little bit later on, but from an application point of view, all of these APIs and the protocols for accessing data are abstracted away into our SDK. So your application just has to embed the library of whatever language you are working with. You have a single instantiation of the cluster, and then you have a variety of APIs that you can access data with Couchbase and our software, abstracting the topology and the protocols and the ports and all of that away from you. So at one hand, you have your key value operations. This is when you know the primary key of the document that you're looking up, and you can build some or all of your application logic on top of that. That's also where we support MapReduce views, which are a way of aggregating data within Couchbase. There's also NCL queries. We're going to talk about NCL in just a minute, but this is our SQL-like query language that has been extended specifically for JSON. We then have full text search, and the difference we'll touch on a little bit, but the difference between query and search. Query is really that structured query where you know what parts of a record you are looking to match. You have a rough idea of what you're expecting to get back. Search is what you might imagine much more of a Google-like search where I don't really know how to spell what I'm looking for, or I don't really know where it is within some free-form text. And I might want what I searched for, but I might also want a little bit more than that, or I might want a little bit less than that. And that requires a slightly different way of asking the question. So that's where query and search come together. And then we are building in, this is in developer preview now, but we're building in a real-time analytics layer. And you might be asking why a separate way of querying data. So our query interface and our NCL query engine for right now is designed for fairly high performance, high throughput transactional queries that are touching relatively small parts of the data, where you're using a well-defined index much in the same way you would a relational database. What we found was organizations also want to be able to do much longer running or relatively longer running ad hoc queries going over the whole or a larger portion of the data set and returning a much larger result set. Not something that you might put in the critical path of your user application, but certainly something that you need from a business intelligence and an analytics perspective. And so we are creating have created a separate query engine and service within Couchbase to provide those. That's in developer preview now, and will kind of walk along the path to beta and GA over the coming months and releases. So let's go into a couple of these in a little bit more detail. First, if we look at Couchbase querying, and when Couchbase we talk about querying, we separate that a little bit from our key value lookup or CRUD operations, where you know the primary key of the document. Querying for us is using our query language called NCL, in most cases using an index across the data to support that query, and then returning a result set back to the application. It could be one or more documents. If you're familiar with SQL, you're going to be familiar with NCL. This may look like a SQL query, but it's also a NCL query. At these fairly simple levels, the two syntaxes look exactly the same. So NCL has all that you would expect from DML, DQL, and DDL, being able to define indexes, being able to mutate data, being able to query it. But all of this is what SQL has and what we brought up parity with. But on top of JSON, there are some things that SQL is missing. And so if you imagine a JSON document of a nested hierarchy, maybe an array of nested objects, The SQL language doesn't have the words to describe that. There's no way of saying I want to access a field that's 4 layers down in each element of an array. And that's where we extended SQL to become Nickel. And so some of the things that we added, this idea of nest and unnest, which allows you to manipulate hierarchical objects within the query. And another common thing that we find with JSON, especially as your schema and your data model evolves, you might have one record of a certain type sitting right beside another record of a certain type, and there are different fields, because as you're adding fields or removing fields. And so we had to introduce this concept of missing. So whereas SQL, everything is in a very structured table and a value has to exist. It may be null, but it has to be there. Within JSON, it doesn't have to exist, and you need a way of expressing that. And so Couchbase with Nickel, we added the concept of missing so that I can say, give me all documents where this field doesn't even exist, or give me all these documents where the field does exist, knowing that there may be some where it doesn't. And so there's a couple more examples as you get into the language. We have great tutorials online, great training sessions. But to get started, it is SQL at its syntactical level. We also have indexes that you might define, whereas Nickel does support ad hoc queries. That's equivalent to a full database scan. And so for any sort of production environment, you want to define the right queries. The nice thing about Nickel that we've made sure to focus on, you can create an index on any level of the JSON. So any nested level, any arrays, you can create a point index on it, and that helps speed up the query dramatically rather than having to pull over large JSON objects and parse them on the application side. So one of the concepts that we get into quite a lot of conversations around data modeling and whether to be normalized or denormalized. A big challenge with kind of most NoSQL databases, is that they require a large degree of denormalization. They force you to denormalize everything, which ends up with not only data duplication and explosion, but also a struggle with consistency when you have to update one field or one piece of information that's shared by many, you have to update in all of those places. And on the other hand, relational databases force you into very, very strict normalization of data. And while that helps kind of keep data explosion down, it makes it very hard to expand your data set and your data model. With Couchbase, applications and your data model, you can choose a hybrid normalized and denormalized model wherever it makes sense. So if we look here, we have a typical kind of customer document. Sorry that it's grayed out a little bit here, but you might have, and this is an example of a denormalized data model where you have their credit card info included with their email address, included with their address and their first name and last name, right? In a relational database, this would be at least 3 or 4 tables, and you all know that your applications are many more than that. But Couchbase, because of JSON, we give you the ability to denormalize the data where it makes sense for you. But now let's say we wanted to start adding purchase orders for this customer. One option might be to duplicate all this information every single time. Right, that would be a very denormalized way of doing it. And we'd end up with not only data duplication, but the inability to change a field in one place and have it be consistent across all of them. Another approach might be to start embedding the purchase orders into this one document. And that may be simple enough to start out with, but it leads you to a document that is going to be growing uncontrollably, or at least unbounded. And that's going to introduce other performance and kind of data manipulation challenges. So what do you do in Couchbase? We create purchase order documents that link back to our customer document. And so you see here, we haven't duplicated any of the information. We've only put their individual purchase order information in each of those documents. And this field, customer ID, points us back to the customer document. This way we can read one or all of them and get a complete view, but we don't have to worry about changing the first name or last name of this customer and having to change it in tens or hundreds of other locations. Now, where the beauty of this all comes back around is with Nickel, we support joins. And so that's relatively rare amongst other NoSQL databases, but within a single Nickel statement, you can join your purchase documents to your customer document and get back just the information that you're asking for. And so this query is saying, get all of the email addresses from the customer document, join it with all of the purchases and count them up, and then return that back to me grouped by the email address. And so this is relatively simple, but you can see the power that Nickel provides you, whereas without that, your application would be doing a lot of back and forth trips to the database, allocating memory to handle each one of these documents, traversing the tree. Nickel allows you to push that down, push that processing down to the database layer. Okay. The last thing we'll talk about from a development perspective is our full text search. Whereas Nickel is based on SQL and is a very structured query language, full text search is a little bit more involved and has an API around it where you can specify all sorts of different parameters to the search that you're doing. If any of you have used Elasticsearch, the concepts are going to be very, very similar, but this is built into Couchbase, so you don't have a separate layer to manage. It was written by us from scratch with another open source project called believe that we developed and have an engine and then the corresponding client library for doing all sorts of full text manipulation, stemming and scoring and relevance-based matching. Okay, I think I'm doing pretty well on time. Let's move on to the operations side of things. So all of that development experience, one of the key benefits to remember with Couchbase is all that you have developed does not change no matter how you are deploying. So if you're running Couchbase on your laptop, if you're running it against a test cluster of VMs, whether you're deploying it to a 100-node cluster in the cloud, the behavior of the application doesn't change. So you don't need to re-architect the application, which allows you to get this separation of development concerns from operational concerns. Certainly those two are closely linked in the world, in the DevOps world, but you want to be able to make changes at an application level or make changes at the database level without having to synchronize those two or introduce any downtime. So let's talk just briefly about the architecture. We saw this earlier from an application point of view. Within Couchbase, we have introduced a few of these kind of key points. So every node is the same. Every node has the ability to run all of the workloads and all of the services. So there's no need to worry about separate layers for configuration, separate monitoring, things like masters or slaves, head nodes, config nodes, name nodes, all of that goes away. A Couchbase node is a Couchbase node, and all of its functionality is configured at runtime. Excuse me, the internals are broken up into what we call services. And this kind of roughly translates to the different workloads that a cluster might be performing. And we're going to talk about that a little bit later on. But in this context, they are separate processes, and they can be turned on or off per node at runtime. And then finally, there's a cluster manager running on every node. And this is the process that holds the cluster together. It manages startup and shutdown of processes, management of statistics, logging, all that sort of coordination. If we take a quick look at kind of the flow of data from an application into the database, you'll see that all of these services exist within a cluster. And as I mentioned before, there's no need for a load balancer or a proxy layer or a routing layer. The application itself, our intelligent SDK, manages all of the load balancing and all of the connectivity. So from an application perspective, you see a single point of connection into your cluster, but it may actually be spread across many nodes underneath. And yeah. So if we take a look at this picture, it may look like we're talking about one node with multiple services running in there. We can be, and that's possible. You can run all of your application on top of a single node of Couchbase, which is useful from a development perspective. But this may also be a cluster underneath where each of these services is deployed across one or more nodes in a distributed fashion. And that leads us into the idea of how do you scale a cluster of Couchbase. Historically, and with most database technologies, all of the workloads, be it storing data, querying data, indexing data, all the things that a database is being asked to do, historically have been spread across every node of a cluster. And that may be fine, and that may suit your needs. But what you start to find is that each of these workloads is doing slightly different things. Querying is more CPU intensive. Indexing likes to be consolidated to a few nodes rather than spread across an entire cluster. And so you want to be able to control that. And with Couchbase, we have this concept of multidimensional scaling, which allows within a single cluster to segregate those services, dedicate specific groups of nodes to each of them, and then scale them independently. And so you may want to provide more CPU power to your query nodes. You may want to provide more RAM to your indexing nodes. You may want to add more nodes to scale out your database, your data storage layer, all without changing the behavior and interaction of each of these pieces. And a very important part of this is the ability to change these topologies, adding nodes, removing nodes, upgrading the software, moving from one piece of hardware to another without ever taking the database down. And that's a really key part of Couchbase and a key part of the simplicity of our management, being able to upgrade our software versions, being able to upgrade the operating system, being able to change topologies, moving from one node with all services on it into a more scaled out 7, 10, 20 node cluster with those services segregated. Because the application is aware of the topology, you can do that without ever taking it down and without ever changing its behavior. So that's pretty much it. Just a couple more points before I hand it over to the demo team. We didn't talk too much about it, but Couchbase has cross-data center replication, whereas other technologies talk about spreading a cluster across many nodes, spread across other databases, other data centers, and geographically, Couchbase focuses on individual clusters existing in as many geographies as you want, and then linking them together with unidirectional, bidirectional, and/or filtered replication. That allows each cluster to operate independently, even if the network connection is brought down, allows each cluster to be a different size, allows each cluster to be upgraded independently, and provides for much greater flexibility in managing a geographically distributed database layer. Backups and restores are possible with Couchbase, done all online. So you can take either a full backup or incremental backups, and then restore that backup to any point, any incremental point in time, or any topology on the other end. So you don't have to restore back to the same cluster that you took the backup from. And lastly, security. So security within Couchbase, we have split out into the idea of administrative and data access security. But the concepts across them are very, very similar. So both administrative and data security has authentication. So either through LDAP, PAM, or our own built-in users are defined how you authenticate to the database. Authentication is saying I am who I say I am. Authorization, saying what my user is allowed to have access to. This is where things start to diverge a little bit. So from an administrative perspective, you want to control who can add or remove nodes to the cluster, who can view the statistics for which data set, who can create cross-data center links. From a data perspective, you're controlling who has read access, who has write access, who can perform a query, who can create indexes. And so we have a number of very granular roles that can be defined for all of the users and applications accessing Couchbase. Auditing is an important part of security. At the administrative layer, we already have an access log that allows you to audit who did what at every layer. At the application and data layer, we're working on rolling that out as well as an upcoming feature. And then finally, encryption. From an application perspective, this is about securing the APIs, providing SSL or TLS encryption to your administrative access to it, as well as securing all of the passwords, secrets, and tokens on disk. From a data perspective, this is encrypting data from the edge, over the wire, and on disk of a cluster. So this is a comprehensive security model that allows plugging into external systems, but also kind of supported within Couchbase by itself. Surprisingly, I'm right on time. So I thank you very much for giving me the opportunity to give you a very fast overview. But now I'd like to hand it off to our wonderful demo team who's going to show you some of this in action. Thank you.